Is chapter 6, 6.1. This is about the normal distribution and the curves. Suppose, remember in chapter 5, we had the random variable x, which was discrete, right? That means the value of x can take only finitely number of times. But here, under the normal distribution, we need to assume that our random variable x is continuous. That means our variable x can take infinitely many values. Okay, so keep in mind that point. Then, if the random variable has a probability distribution whose graph is continuous, bell-shaped, and symmetric, which is called the normal distribution. The equation of the normal distribution is given by y. We denote this as y, which is e to the power minus x minus mu whole thing squared over 2 sigma squared, where mu is the mean of the random variable x, and sigma is the standard deviation of the random variable x. The E is the constant value, which is 2.718. This is the fixed value. And of course, so you have some constant is that is 2 pi. So where pi is, approximately 3.14. So now, if you draw a curve of this distribution, normal distribution, which will be, the symmetric and bell-shaped curve. Okay. So when you draw a symmetric and bell-shaped curve, the middle line always going to be the middle line, the midpoint of this distribution. So this is my random variable x. X may have infinitely many values along x-axis. So this is, you could think of the real line. So your x values are in real line. So you may have any number from negative infinity to a positive infinity. So x random variable may have any value between negative infinity to positive infinity. So my curve is now, the continuous curve. Okay. So the midpoint of my distribution curve is nothing but the mean point. That is, the mean point. Okay. Suppose if suppose if mu is 0, that means this value is going to be now 0. So mu may be any real value, maybe 2, maybe 6. If you look at this picture, the third picture here, so the middle point is 2. So middle point is always going to be the mean of the problem. And the standard deviation will be given in the problem. Okay. So if you move to the next, so you will see the properties of, the theoretical properties of the normal distribution. The normal distribution curve is always bell-shaped. The mean, median, and mode are equal and located at the center of the distribution. So mean, median, mode are at the center point. A normal distribution curve is a unimodal. So that means we will have only, one peak. You see the peak of your distribution is somewhere here. That is going to be the mode. So you will have only one mode for the data distribution. Therefore, this is a unimodal. The curve is symmetric about the mean. Yes, symmetric about the midpoint mean, which is equal to saying that its shapes is the same on both sides. So the symmetric means the distribution of the curve will be same in both sides. The curve is continuous. That is, there are no gaps or holes. So you could draw the curve like without lifting your hand. Therefore, this is a continuous curve, the curve never touches the x-axis theoretically, no matter how far in either direction. So if you look at the curve never touch x-axis. Curve is going all the way, right, to infinity, to the positive infinity in the right side and towards the negative infinity, in the left side. So it is not, touching the x-axis. It never touch. The total area under the normal distribution curve, if you find the total area of the curve, always going to be 1. The total area is 1 or 100%. Okay. The area under the part of the normal curve that lies with one standard deviation of the mean is approximately 0.68 or 68%. Within two standard deviation is about 0.95 or 95%. And within three standard deviation is about 0.997 or 99.7. What does mean by that? That means if you have, look at this picture. So if you find the area of this region, that means what? Area within mu plus 1 sigma to mu minus 1 sigma. This is called the area between, one standard deviation. So this area is basically, this area is approximately 68% or 0.68. If you look at the region I have colored here, if you look at carefully, this region is symmetric about mean. Therefore, the right side area is half of 68%, which is 34 roughly. So which is 34% of 0.34. So similarly, the left side area also will be same because of the symmetric, right? But if you find the area between, within a two standard deviation, that means this area. Now, if you look at the area between, mu minus 2 sigma and mu plus 2 sigma, so this area will be always how many percentage? 95% of the, entire area. So that is roughly 0.95. Okay, so these are kind of theoretical properties. So finally, if you look at the area of the region within three standard deviation, that is mu minus 3 sigma to mu plus 3 sigma is almost 99.7%. That means 0.997, right? Very close to 1. That means roughly you can approximate the area between, mu minus 3 sigma to mu plus 3 sigma is always 0.997. Okay. So this is kind of a rough idea, theoretical properties of, the normal distribution curve. Okay. Now, the normal distribution and the skewed distribution. So we have already seen about, the skewed distribution in the past chapters, and you could go over this. Now for the normal curve, we use always this kind of shape, right? Bell-shaped and symmetric. So it is symmetric. Okay. That is about the normal distribution. Okay, now we will move to the next one, which is called the standard normal distribution. Remember, for the normal distribution, your random variable x may have any mean, any value, real value with mu, and the variance may be any value, which is a sigma squared. Okay, but if you consider the special case where mu is 0 and the standard deviation 1, the special case with the normal distribution, which is called the standard normal distribution. Standard normal distribution is a normal distribution, but with the mu is 0 and the standard deviation is 1. So when you fix your mean 0 and standard deviation 1, those kind of normal distribution curves are called standard normal distribution. In other words, if you are given a standard normal distribution, it is understandable that the mean is 0 and the standard deviation is 1. Okay. Now we use the little z for the random variable, which is standard normal. Okay. So the standard normal random variable is denoted here throughout this course as a little z. So if you look at the distribution of the standard normal, the standard normal distribution formula is always much simpler than the normal distribution, right? So this is the equation of standard normal distribution. You don't see it here mu and sigma because we know the values of mu and sigma, right, for the standard normal, because mu is 1 and the standard normal, mu is 0, sorry, and the standard deviation is 1. So if you're plugging mu 0 and standard deviation 1 to your normal distribution function, earlier we had that. So if you look at, if you go back and check your normal distribution formula, and if you replace mu 0 and the standard deviation 1, then of course you will get the similar formula, sort of formula to this. Okay, so these all kind of theoretical explanations I'm giving. Okay, now this is the catch. If x is a normal distributed random variable with mean mu and standard deviation sigma, this could be any numbers, then little z is a standard normal distributed random variable with mean 0 and standard deviation is of 1. Okay, so now what is the connection between z and x? Well, this is the connection we have. The standard normal is always given by the normal distributed random variable, subtract its mean and divided by its standard deviation, right? So if you know the mean and the standard deviation of the random variable x, then subtract the mean of the random variable x and divide by the standard deviation of that random variable x. Then you will get the new guy. That is going to be my new random variable, which is a standard normal random variable, which is z. Okay, so this is the connection we have between z and x. Okay, so in summary, so if you want to draw, you know, standard normal, then I'm using z. Standard normal curve, also bell-shaped symmetric curve, but the center point mu is now we know 0, and the standard deviation for this distribution is 1. Okay. Now, um, look at these different scenarios here. Finding the areas under the standard normal distribution curve. How are we going to find the area of the particular region of standard normal distribution curve? Well, we are going to look at, some procedures on finding the areas of the given standard normal distribution. Suppose if you want to find the area of the region which is left side of some given z. Okay, so you could find this area. Suppose if you know the z value, suppose say z is 2. Remember, I'm using for the standard normal, therefore center point is 0. Okay, Suppose if you want to find the left side area of the z value 2, how do you find that? Left side area. You could find the left side area by using the chat or table. So I have already uploaded that in Georgia View under the table. Go to the content and there you will find the tables. And let me browse the tables here. And now we are going to use a standard normal distribution table to find what? To find the left area of the given, given any z value. For this example, we are going to find now, the left side area of the point z, which is 2. Okay, how are we going to find? Okay, so we are going to look at the table. So if you open the table, so you will find a bunch of tables here. We are going to use table E, that is the standard normal distribution table. Now remember, these values, the inside the box values are nothing but the area of the normal distribution curve. Remember, the maximum area is the total area of the curve is maximum full area is always 1. So if you look at your table, so table continues to second page. So you will find the maximum value here is 0.9998, almost 1. Okay. So how are we going to find the left side area? Well, so you just look for the values for z. My z value for this particular problem example is 2, right? Therefore, you have to look at the z value, which is 2 in decimal point. This is 2 means 2.0, right? So you have to look for the z value, which is for positive 2, right? So I will show you. Look at here the z value, and we are looking for the positive 2. These all negative values. I need the positive values, right? Therefore, I'm continuing into second page, and there I will find the 2. So if you look at 2.0, 2.0 and the 0 column is the one I need. That is simply 0.9772. 0.9772. That means the left area of that point. So this area, if you find the left area, that is simply the left area is simply sorry 0.9772. Okay, so that is very close to 1, right? So that is the way to find the left area of the point. Okay. um, Here I have included several examples, and we will find one by one answers. Okay, so let's look at example 1. Find the area under the standard normal distribution curve to the left of z 1.73. Okay, so I'm going to draw a picture here. So first of all, draw the standard normal. Remember, the midpoint mean is always 0 for the standard normal. So we use little z for the standard normal random variable value. Now we are going to look for what? For the area corresponding to the z value 1.73. Remember, 1.73 is a positive number, therefore it should be right side of 0. So 1.73 will be somewhere here. Now which area I need? Let me change the color. So I need the area of left side area of this point. Therefore, we are looking for this area, left side area. Okay, how can I find? Use a standard normal distribution table, and the table you will find. So I'm using that table. Now my z value is 1.73. Okay, so we have to look for 1.73. Remember, if you look at the first column, you will see 1.7, but the remaining 3 will be, in the second decimal point. So it's going to be 0.03. It is in my fourth column. So my fourth column with 1.7 is going to be 0.9582, right? Therefore, the area, the left side area to the given point 1.73 is 0.9582. So 0.95. Therefore, the area is 0.9582. So this area is 0.9582. Okay. So one more time, I'm telling you, if you find the value inside the table, always will give you the left side area of of your z value, left area. Okay, now look at the second scenario. What is the find the area under the standard normal distribution curve to the right side of negative 1.24? Okay, now first draw the picture. 0 is here, middle point. Now I need to find out the z value, which is negative 1.24. So negative value is, this is my z. Negative is always left side of 0, right? So negative 1.224 will be somewhere here. But which area now we are looking for? We are looking for right side area. Right side area of this negative 1.24. Therefore I need the right side area of that. This is the area I need now, right? Okay, so now you need to think a little bit. Remember, if you look at this z value in your table, remember table always will give you left side area of the point, okay? So if you look at your table and find the area, table will give you always left area. This is the area, right? This is my left side area. So table will give you always left side area. So first let us find the left side area. Okay. So I'm going to look for the area which is corresponds to negative 1.24. So let us find negative 1.24. So now I'm going to look at negative 1.2 on the first column. Negative 1.2, but I need a 4. 4 is in my fifth column, right? This is 4. 1, 2, 3, 4, fifth column. So negative 1.24 will be 1, 2, 3, 4, 5. So negative 1.24 will be 0.1075. 0.1075. So 0.1075. So the left area is 0.1075. Okay. So far we have found left area of the point, but I need to find out the right side area. How do you find that? Remember, the total area for the curve is 1, right? The total area is 1. Therefore, table is given 0.17, This is my left area, remember. To find the right side area, therefore the right side area is simply subtract that left side area from the total area, right? The total area is 1. Therefore, you subtract that 0.1075 from 1. Then you will get the right side area. Okay. So what is that? Answer. So that is the area I wanted. Okay. Okay, good. But the good thing is, you could use the calculator to find the area of any, standard normal or normal curve. How do you find the area? So to find the area, okay, use this function from your calculator, which is called the normal CDF. Now put the left bound of your area and the right bound. These two are just numbers, okay? First figure out the area, which one you want to find out, then put the left bound and right bound of that area, okay? Then this will give you directly the area. You don't need to, subtract it. So simply you just put the, the bounds of the area. So directly you will get. So let's look at how to find the area for this example 2, okay? Okay, so I'm showing you how to, find this function. Go to calculator. Go to the calculator and follow these steps. Follow these steps. Press the second button with VAR button. Then choose number 2. Number 2 is nothing but normal CDF. Okay. Okay. So now if you look at the area I want here, we are looking for the right side area to the point negative 1.24, right? If you look at that area, there are two bounds always, right? So the left side of that area is bounded by negative 1.24, but the right side is going all the way up to infinity, right? The positive infinity. Therefore, the two bounds for this area is negative 1.24 and infinity. How do you type infinity in your calculator? Okay, if you want the positive infinity, type this as the positive infinity, positive E99. And if you want negative infinity, then type negative E99. So E99 is the code we are using for infinity in your calculator. Okay. Now here I need what? I need the normal CDF of the area bounds, okay? My left area bound is negative 1.24. My right side area is infinity, right? But how do you type infinity in your calculator? Simply type E99. Type E99. This will give you your answer. So let's see. So go to the calculator and find out the second button and VARS button. Obviously, that is distribution. Now go to number two and type. There you need to plug in now the two bounds, okay? So I'm going to type negative 1.24, comma, E. How do you type E? E is there, the shift button, the second button with the comma will give you E. Then I need to know 99, yes. Then close the parenthesis and just enter. You see, I got now the 4 decimal place answer as 0.8925. So this is directly, giving you a right side area. This is the one I was looking for, right? You see now we got the same answer by using the table, right? So calculator will make everything easier. So whether you are asked left or right area, doesn't matter. You just simply plugging the bounds of the area, you will get the answer directly. So this is the very good thing we have, when you use the calculator. But if you want to use the table, then that's a problem. Table always will give you left side area. Suppose if you want to find right side area, find the left side area and subtract from 1. Okay, that's up to you now. So you could do the problem in either way. Okay, so hereafter I'm just, I'm going to use the calculator. So number three, find the area under the standard normal distribution curve. Okay, so let me draw first the standard normal distribution curve. Yes, this is my curve. 0 is here. Now which area we are looking for? We are looking for the area between two values, which is 1.62 to negative and negative 1.35. So negative 1.35 will be somewhere here, and positive 1.62 will be somewhere here. Therefore, we are looking for the area between these two values. That means simply this value, right? Okay. But I'm going to use the calculator. So what is this area? This area is simply normal CDF, normal CDF. Then what is the bounds for this area? Remember, my left side area is negative 1.35. Then put the comma, and the right side area is 1.62. That's it. Okay. So then this will give you, the area. So this is the easy way, when you use the calculator. So let me type those things. Go to second, var, normal CDF, and type the two bounds. So negative 1.35, comma, or 1.62. Okay, that's it. Just enter. So you will get what? I'm always writing 4 decimal places. So which is going to be 0.8589. 0.8589. Okay, so this is the easiest way using calculator. But how do you do this problem if you want to use a table? If you want to use the table, you have to be very careful. You need to first find the left area for negative 1.35, subtract from 1. That means you will get everything, this including this uncolored to the right side area of 1.62. Then find the area for 1.62 to the left, then subtract from 1, then you will get that small area, tiny area. Then you have to subtract that tiny area from your previous area. So you have more work typically, if you want to use the table. But the calculator is always, will give you a very shortcut. Okay, let's look at that note. Now we are going to see then what is the connection between the probability and the area just now we found. So this is the connection. Suppose if you have area, okay, suppose if you have area for the normal standard random variable z between two values, say A and B could be any number, we don't know. So in general, I'm taking A and B as these two numbers. Suppose if you have that area between these two z, the values, that means the probability of having z values between A and B is simply the area just now we found. So this is simply the area, okay? Simply the area between these two values, okay? So these are the connections, right? Suppose if you are asked to find the probability of the random variable between two values, that is simply the finding the area between those two values, okay? Now we know how to find the area, right? For the calculator use, if you want to find the probability of the z value between two particular values, this is nothing but the area, which is a normal CDF between A and B, right? So this is the connection between the probability and the area. Okay, look at this example. If you are asked to find these all probabilities, simply find the area for the corresponding regions. Okay, so now let's look at these examples. So the first one, find the probability for each area. So let's look at the number one. So you are asked to find the probability of B in your standard normal random variable between 0 to 2.53. So the equation sign, will not give any, difference. So therefore you could include or exclude. So how do you find this? This is nothing but if you look at the picture, so I'm drawing here on standard, random variable curve. Now I'm going to look at the area between 0 to 2.53. 0 is here, 2.53 will be somewhere here, and I'm basically finding the area between these two values, this area, right? So the probability of being 0 to 2.53 is nothing but this area. Okay, so how do you find that area? Well, we know how to find area. Simply use the calculator with the normal CDF. Okay, put the bounds for this area. This area bound is 0 and 2.53. Okay, remember this function is valid for what? For standard normal random variable z. Okay, so if you have standard normal random variable, then only you could put only two bounds. Okay, so now let us type these into your calculator and find out the answer then. So I'm going to get a normal CDF. Okay, the left bound is now 0. Come on, the right bound is 2.53. And close this. Enter. So my 4 decimal place answer is 0.4943. 4943. 4943. Yes. So that is the probability of the z value between 0 to 2.5. Okay. So that means okay. Now look at number two. Number two, you are asked to find the probability of your z value should be less than 1.73. First of all, draw the picture and find out the corresponding area. So remember, sorry. First of all, draw the normal CDF, standard normal CDF curve. Now, where's this region? Your z value should be, this is 0. should be less than 1.73. 1.73 is the positive number, so it should be somewhere here. But now you need to find the area. Area is what? Area is any z value, corresponding z value, which is less than 1.73. So less than 1.73 is left side of 1.73. That means these all the region, right, is going to be my region. Okay, so this is the corresponding region. So find this area, that is basically this one. Okay, right. So now the thing is, how are we going to find CDF? The bounds. Remember, the bounds for this area is the left side is all the way going up to negative infinity, and the right side is 1.73. Therefore, bound is negative infinity, means negative E99 from your calculator, and the right side is 1.73. That's it. Simply you type this function and values, and you will get. Okay. So therefore, find the corresponding region and then area. So therefore, I'm going to type second with var and number 2, and the left side is negative e e99, close the parenthesis. Oh, no. And e99 comma, my right side is 1.73. Okay, then close that. So simply find that area. So which is 0.9582. So 0.9582. That is the area. Okay. Similarly, for number 3, so you are asked to find the probability of z which is bigger than 1.98. So if you look at the picture here, so that is going to be 0 is here. So 0 will be somewhere here. This is z. Okay, now z should be bigger than 1.98. 1.98 somewhere here. So bigger than means right side of this value, right? Now this is the area we are looking for. So that means the left bound of this area is 1.98, and the right side is going all the way up to positive infinity. Therefore, this probability is nothing but the area to the right side of 1.98, which is normal CDF of left bound is 1.98, comma, the right side is now positive infinity, which is E99. Okay, now simply find out this. So go to this normal CDF and type the bounds, that is 1.98, then comma, E99. So which is 0.0239, 0.0239. So very small probability, right? Because this is very tiny area. That's it. Okay. Okay, now example 5 is in another way, right? You are given the area, but we don't know the corresponding z value. Find the z value such that the area under the standard normal distribution curve between 0 and the z value. Oh, now we don't know the bounds, one side bounds. So if you look at the picture, 0 is here, okay? The area they are talking about what? 0 and 0 and another side, we don't know z value. This is the one they are asking us to find out. But you know the area now. In between area is given. In between area is 0.2123. So find the z value such that the area under the standard normal distribution curve between 0 and the z. Okay, how are we going to find that? Okay, now here also to find to find the corresponding z value, we have one function which is called the inverse norm function in your calculator. inverse norm function. But here, if you want to find any z value, right, you need to plug in a left area of that point. Okay, find out the left side area, interior area left to that point. Then that will give you the z value. Okay. Now, if you look at this picture, remember, if you have normally distributed standard normal distribution curve, what is my right side area of 0? Remember, this picture is symmetric about the midpoint 0. Therefore, the total area we know is 1. Therefore, the right side area should be half, and the left side area as well, right? Half, half, both sides. Therefore, if you look at this picture here, what is my left side area? Left side area to this point, the in-between area is now given 0.2123, but now uncolored area, left side area is half, right? Why? Because of the symmetry, this side area is always, half. That means the total left side area to that point Z is nothing but half plus 0.2123, right? Therefore, the left side area of Z is nothing but half means zero point 0.5 plus this tiny area, the colored area, 0.2123. Then what is that? So if you add these two, that is 0.7123. So this is the total left side area to that given point Z, right? We are looking for that Z. So now plugging this left area, 0.7123, into your inverse norm function, then you will get the corresponding Z value, okay? So now I'm going to, find the value for the inverse norm function. Left side area to that point is now 0.723. Okay, so let us find that. So now I need to figure out the inverse norm function. Where is that? It is going to, again, second one. You will see number 3, inverse norm function. And now type the left side area. So I got now left side area is 0.7123. Okay, now that's it. Just enter. So you will get now corresponding Z. So my Z is now, let me write down in 2 decimal places. My Z value is 0.56. What does mean by that? That means if Z is 0.56, then the area, the area between 0 and 0.56 is 0.2123. So that's the meaning. Okay. So you could check whether that is correct or not. We could check whether we got correct the Z value. How do you check? If you find the area between 0 to the value we found, 0.56, it should be 0.2123. Let us check that. So I'm checking the area now. So I'm checking the area, therefore normal CDF. I'm checking the area between 0 and the one we got just now, 0.56. Okay, what is that area? That area is very close to the given area. You see, 0.212123, right? Correct. Therefore, I got correct, the corresponding Z value. Okay, so that is the way to find the Z value if you are given an area. That's it.